Hi there. Thank you for agreeing to participate in our user study. We've created a new algorithm that we call Motion Edits, and it's a type of AI tool that you can use to edit videos. Basically, you can change where things are and when things are. So we have before dots and after dots, and this will make more sense in a second. But to give an overview, let's say that we have this simple video sequence that I drew for illustration. We have a guy that roasts a marshmallow and then eats it while the dog sleeps next to him. But let's say we want to turn this video into a video where he doesn't roast the marshmallow and instead feeds it to the dog. How would we do that? Well, we have that input video, and the change that we want can be explained by differences in motion. After all, if that marshmallow was not being roasted and was instead being fed to the dog, that could be explained by if the marshmallow was up more on this frame and to the right more towards the dog in this frame. But that's not enough because the dog also needs to move up. So we'll take that dog head and we'll move him up at the last frame. So how are we going to communicate that to our AI model? I'm not going to tell you the architecture right now because this is about the user study. But effectively, we can think of it as before and after trajectories, where the before trajectory is where the marshmallow was before our edit, indicated by these dots over here. And the dog's before trajectory is actually just the same in all the frames, so it's just a flat line here. And the after trajectories are where we want them to go, so we have dots in new positions. Now, we have two videos. We have the before video and we have the after video, so we're going to separate these out. And yeah, the before video has our before tracks, and our after video will have our after tracks. Let's clean this visualization up a little bit, get rid of those arrows and get rid of these lines, and now we just have dots. The dots are colored according to what they represent. So here, the yellow dot is the marshmallow, and the purple dot is the dog's head. So what it means is that in this video, the input tracks just track the marshmallow throughout the entire input video, and the output tracks where that yellow dot is tell us where we want that marshmallow to go. Same with the pink dots, where we're basically telling it where we want the dog's head to go. So colors correspond to an object being moved. And we feed that information into the diffusion model, and it denoises it, and it denoises it, and voila! Our motion editor model can take in an input video plus pairs of dots and generate the output that we want. Here's a diagram. Feel free to pause the video if you need to look at this a little bit longer, but the TLDR is our model takes an input video plus source tracks and target tracks, and as an output will create a new video with the corresponding motion edit. So let's take a look at a real example. We have a Bichon on the left, a white fluffy dog, and we have the Corgi on the right, the brown dog. All right, here's our input video. And it's a video of two dogs racing, and they tied. But what if I want the Bichon to win the race? I want everything else to stay the same, but I want the Corgi to be behind and the Bichon to be ahead. So let's create a motion edit. So a motion edit will look like this. That's going to be the output that we get, but let's explain how we get there. First, we have to choose the dots that we want to track. In this case, let's just grab the Corgi by the nose, and we'll take that dot and we'll drag it back so that the Corgi lags behind in the race. So we take that point, and first we take a tracking algorithm to track it, so we get our input track. And then we're going to edit that trajectory. let's put the Corgi behind the Bichon. We have our input track that we got by placing a dot on the nose and tracking it. And now the output track, we're going to click and drag that, and we're going to make a new trajectory. See, we would like the nose to follow this new dot, and in the output it does. This is not quite all we need to do, though. We actually need to specify a little bit more than just the Corgi, because we need to make sure that the background doesn't change too. So we're going to add some more points. We're going to add some points onto the Bichon, and we're going to add some points to the background on the house over there. We're going to add some onto the light pole, onto that car. Note that when a dot disappears, it means something occluded it, meaning something went in front of it and you can't see it anymore. So that's what it means when a dot disappears. And yeah, we're going to add all these tracking points, and this is what we actually gave to the model. When I showed you just doing the Corgi, that was just for visualization to explain it, but actually we're using more dots to make sure that the background doesn't change. It's just that these ones aren't being changed, we're just leaving them in the same trajectories that they came in. And that's how we can make the Bichon win the race. So, I want to point out something. Did you notice that this power pole wasn't in the beginning of the video? Let's watch that again. Look at the first frame. Pay attention that this power pole was not in the beginning. See? It's not there. And we play the video again, and it appears in both videos. The only way that it could have known that that power pole is there is because we feed it the entire video as our input. And that's what makes our algorithm do true video edits. Even if you can't see the object in the first frame, there's a dot, number 7 over here, that corresponds to number 7 over here, that even though it eventually disappears, and in the first frame it wasn't visible, just by being somewhere in the middle of the video, that dot number 7 tells the output to put the light pole there. Now, this is in contrast to other methods of editing videos, which would often just take in the first frame. So this is called an image-to-video model, and this is what our baselines are made of. ATI is a new model based on a stronger base model than ours, but it completely misses the power pole. And it completely misses the power pole because it couldn't have known that it was there, because it's an image-to-video model, and that power pole wasn't in the first frame. This is what makes our model true video editor. So let's take another example. Let's say we want to zoom out of this swan and freeze the camera. Here's our input video, a classic video, and we're going to apply motion edit, and we're going to get this video as an output. So again, same procedure. How do we do it? Well, first we need to choose some points. We're going to place some points on that swan, and to zoom out, we're going to need to make that swan a little bit smaller, and we'll get to that in a second. All right, so we're going to take those points, we're going to edit them by making the swan smaller and make the swan move from left to right. So that's going to be the new trajectory of this one. So we've zoomed out, but what makes the camera freeze? Well, I haven't shown you everything yet, just like with the dog. There's actually more points that we need to add to stabilize the camera. So we're going to add more points onto the background to make sure that the background doesn't move. Now, the input video, the background does move. So all these new dots, we're going to need to motion edit them to stay still. There we go. And in the new trajectories, they don't move. Notice that more dots are being revealed throughout the video as the swan is going from left to right. So you can see that these dots are appearing and disappearing as the swan goes. You can think of this as the small camera revealing these dots. And it's really cool that this works, because when we have an input video like this and we zoom out, let's take a look at one of these patches. Even though these are different images and we zoomed out, these patches have the same weed on them in the same place. Because this track, the number 10 over here, this green dot, is supposed to be the same as this green dot over here. And it's pretty close. You can see the same weed is over here as over here. Image to video models, like, they literally can't do this task because there are no frames in common. When we zoom out, the first frame of this video is different from the first frame of this video. And so is the second frame and the third frame. All the frames are different. Only a true video editor could change this and do that edit properly. So your job is to do a user study. Your job is to pick the best edits. We have a bunch of baselines here, and we're not going to tell you which one is which because all of them are shuffled. On the left, you'll have an input video, and the four to the right of that are output videos of various algorithms. What makes an edit good? Well, in order for an edit to be good, it needs to have taken information from this input video and dragged it to the output. So, for example, this red dot seems to correspond to this boat. So this red dot should be on the boat in all the algorithms, but you can see that it's in a different place on the boat in some than others. So the question, which is, most accurate, which one is corresponding best to the input video for that color, for the red color and the green color and the blue color. You may notice that some dots, like blue, appear in the output videos and are not present in the input videos. And that's actually because it is in the input video somewhere, just not at this frame. So you may need to go back and forth in the video to find the dots that appear in one frame that are invisible in another video, and you have to go to another frame to find it. So yeah, that red dot corresponds to the same area in all the videos. So this dot is right if this dot corresponds to the input video. Same for this one and that one. And again, yes, it can appear at different times as well. All right, thank you very much. When you're done with the user study, on the bottom, you'll have a form that you can email me. So please do that. Thank you.